Well, buckle up, ladies and gentlemen. We are ready to start with the definition of the derivative. So take good notes. It's a lot of practice today, and we'll get a little bit more in class. So let's just start with some basic terminology. Differentiation and the derivative. Differentiation is the name of the process used to find the derivative. The derivative is the result of differentiation. In short, we could say we derive a function or we differentiate it, and the result is the derivative. What in the world is the derivative of a function? Well, we've talked about this a few times, no matter what previous math course you've had. The derivative of a function describes how a function is changing at any instant, known as the rate of change. It also describes the slope, and that's kind of what we want to get in our head. Every time we say derivative or derive, we are talking about the slope or the rate of change of a function. Notation. For an expression in function notation, the derivative of f of x is going to be read f prime of x. For an expression in x equation notation, the derivative of the equation is dy dx. All right, so we're going to let this again take up about a half a page, this tangent line problem. Now, I know I have those the x-axis numbered. I don't want you to worry about that, so to speak. I'm going to say this point here is x distance away from the origin. Therefore, to get the point on the curve, if its x value is x and this function is f of x, the y value then is f of x. For example, if I went out to 2, this would be the point 2 comma f of 2. If I went out to 1, this would be the point 1 comma f of 1. Now, I'm going to go some arbitrary distance, which I'm going to call h. Therefore, what would that make this value? How far am I away from the origin? Well, I'm x units and h units, and to get that total distance, I would say that this value is x plus h away. Therefore, the corresponding point on the curve is x plus h, comma, f of x plus h. All right, so we're going to start by connecting those 2 points with a nice large line. Okay, as straight as you can there. And this line that goes through 2 points on a graph is known as your secant line. Now, if I want to calculate the slope of the secant line, all I would simply do is the slope formula, change in y over change in x. Okay, change in y over change in x. Now, let's put that in terms of this problem. My y value is f of x plus h minus my other y value, f of x, all over my change in x's, which is x plus h minus x. And if I were to clean that up, you'll notice I get f of x plus h minus f of x all over, of course these x's are going to cancel, so all over h. Now, this is a little hard to see on this one-dimensional graph I have here, so I'll be able to show you something a little better in class. But basically, my goal is to now create a tangent line. And I want you to imagine picking up this red point here and dragging it closer on the curve until it gets to lie directly on top of this blue point. Okay? So let me change colors here. Imagine I take that red point and I move it here. Okay? Now look at the slope between those 2 points. Okay, so I'm moving that red point closer and closer and closer until it lies directly on top of this point. So now picture me moving it right on top, and here's what my tangent line would look like. Okay, so let's label this line as my tangent line, where I just kind of, you can think of it as like a kiss on the cheek. I just kind of touch it once on its side. And I have to apologize, that is an awfully bad tangent line. Sorry about that. Let me change color and draw a much better tangent line. I don't want to go through my graph. I just want to slowly be on the side there. I have to apologize for that, and I don't know where my eraser is at the moment. So ignore that purple line, and there is my blue tangent line. So think about this. What did we change? We want this h value to become as small as possible. Okay? If I were to move this red point from here to the green point, that h value is now much smaller than it was here. Now it goes maybe from here to here. And if I bring it closer, my goal is to make that h value smaller. So the definition of the derivative is, so we said we're making that as small as we can, the limit as h approaches 0. Okay, so I want to make that h value, that distance between them, very, very small. I want it to approach 0, of the slope of the secant, f of x plus h minus f of x all over h. And like I said, I'll have a better visual in class for you tomorrow, but this is the definition of the derivative. Let's get it boxed in and highlighted. The limit as h approaches 0, I'm making the difference between those 2 points small, of the slope of the secant, f of x plus h minus f of x all over h. All right, example 1. Find the derivative of the function by using the definition of the derivative. Now, we're not going to use any of those shortcuts yet. We're just going to pretend that we don't know any of them, and we're going to go about this the very long and tedious way, using the definition of the derivative. So I'm going to start with the limit as h approaches 0. That's never changing. We always want that h value to get near 0. I'm just going to write my rule out. F of x plus h minus f of x all over h. Okay, now, you're just evaluating functions. If I said, what is f of x plus h? You should be able to do that very quickly. I would say f of x plus h is 2 times x plus h squared minus x plus h. Okay, I'm just evaluating f of x plus h. If I said, what is f of x? Well, that's given to us. That's 2x squared minus x. And that's all I'm doing. I'm just figuring out what those two are and plugging them in my formula. So I have the limit as h approaches 0 of the f of x plus h, which is 2 times x plus h squared minus x plus h, minus 2x squared minus x. Now, I'm going to take off if I don't see this on papers. This second term always needs to be either in a large parenthesis or a bracket. That has to stick out separately. Okay, and the reason I want that there is because we have to be very careful about this minus sign. So make sure you have a bracket or parenthesis there. The bracket really sticks out to me. All over h. Now at this point, you've done the calculus. There is really no more calculus involved. All we're doing is cleaning this function up. We're just using basic algebra. All right, so order of operations. Do you square first or do you multiply by 2 first? Hopefully you know that answer. And we're just going to clean this puppy up. So I'm going to get 2 times, FOIL that out, x squared plus 2xh plus h squared. Take this negative sign here, make sure you distribute real nicely. So minus x minus h. Again, make sure you distribute this negative sign, minus 2x squared plus x. We have all of that over h. Okay, now notice my notation. This is in every problem until I literally plug the 0 in. So I'm going to take it down again. The limit as h approaches 0. Okay, it might seem tedious and annoying, but we're going to do things proper. Multiply that 2 through. 2x squared plus, whoops, that should be 4xh plus 2h squared minus x minus h minus 2x squared plus x. Now, here's the test. If you did it right, this second term that you had here should cancel completely. And that's how you know if you did it right. So let's see if we have any goofy typos here. 2x squared and that 2x squared should cancel. This negative x and this positive x should cancel. We know we did it right. Now notice I'm not plugging in 0 yet. Carry that limit down. I've got a 4xh plus 2h squared minus h all over h. Now, somebody out there is going to try to tell me that you can cancel those h's, which is 100% wrong. So let's be careful now. You cannot cancel when you have plus or minus signs. Okay, so basic algebra tells you you have a GCF on top. Let's pull out that h. So I have the limit as h approaches 0. I'm going to take out an h. 4x plus 2h minus, that term doesn't disappear. If I divide h by h, I get 1 all over h. Now I can cancel something because of the operation of multiplication. These h's can cancel. And lastly, I'm going to take my limit. I'm going to substitute 0 into, you don't have to guess, it says h is approaching 0. I'm going to replace every h with a 0. and I get 4x minus 1. And that is my final derivative. Now, since this was a real nice problem, let me just remind you that function was f of x equals 2x squared minus x. If you remember all your power rule derivatives, let's see if our derivative is correct. Power rule says take that exponent, bring it down, subtract 1, I get 4x, and the slope of negative x, of course, is negative 1. So obviously the power rule is a lot quicker, however, we did avoid that using the definition today. All right, number 2, same rule. We're going to evaluate this derivative with the definition of the derivative. So let's get that written out. The limit as h approaches 0, f of x plus h minus f of x all over h. Say it to yourself out loud so you've got it in your head. Evaluate those two functions off to the side. What is f of x plus h, and what is f of x? Well, f of x is obviously radical x minus 2. F of x plus h is x plus h, radical x plus h minus 2. All right, real carefully, let's plug those into our limit definition. The limit as h approaches 0. So it's my f of x plus h, which was my radical x plus h minus 2, minus my x minus 2, notice my brackets, all over h. Now, woo baby, where did you go? All right, we've talked about cleaning up these limits. If you were to plug 0 in, I'd get 0 into h, I'd get radical x minus 2 minus radical x minus 2 over 0. So I'd get 0 over 0, which is indeterminate. So at this point, in order to clean this up, I need to use that conjugate method because I see those radicals. So I'm going to multiply the top and bottom, okay, by the conjugate. So radical x plus h minus 2 plus radical x minus 2, just like we practiced the other day. Remember, we do it to the top and the bottom. All right. Now, we said we're not going to FOIL both. We're only going to FOIL where we see the conjugate because we know terms cancel. So that's the part on top I'm going to multiply. On the bottom, I'm just going to rewrite everything I have. Okay. So on top, when I multiply the conjugate, any radical, I'm foiling, this first times this, any radical times itself is just that junk. So x plus h minus 2. Okay, the middle terms are going to cancel, right? So I'm going to put in them parentheses. And now my last term, so I'm doing this term times this term. It's positive times a negative, so that's minus, bracketing my answer in, x minus 2. Okay, now remember, there's no canceling because we have plus signs on the top here. Just clean up what you have. I have the limit as h approaches 0. Okay, this is going to make this a negative x and a positive 2, right? If I distribute this negative. So my negative x will cancel with this one, positive 2 will cancel with this one, and all I'm left with is h on top. Okay, now again, if you did it right, things cancel, which they did, and I can go one step further. I can get rid of these h's because I'm multiplying again. So I have 1 over this junk. Now, take the limit. We're going to plug 0 into, again, we're not going to guess, 0 into all the h's. So I get 1 over, if I plug a 0 in here, I get a radical x minus 2 plus a radical x minus 2 make 2 radical x minus 2. And again, there is our derivative. All right, in our next example, we need to write the equation of a tangent line to a graph of a function at the indicated x value. All right, so what jumps out at me is the equation of a line. So think back to our algebra days. To write the equation of a line, you need a point and a slope. Okay, we have that point-slope formula. Y minus y1 equals m times x minus x1. Now, what part do you think is calculus? Well, remember, we said the word derivative means the word slope. To get this value, we need to use our calculus or take our derivative. Okay, the rest of it shouldn't be any calculus. Okay, common sense tells you if you have an x value and you want the y value, just simply substitute in to get your y value. So I'm going to find f of negative 3, and f of negative 3 is 1 over negative 3. So the point they want me to use is -3, comma, -1/3. So I'm halfway done. All I need now is the slope, which means take the derivative. So we're going to use the limit process. The limit as h approaches 0, f of x plus h minus f of x all over h. All right, take 2 seconds off to the side, find, x of x plus h and f of x. Pause it, see if we get the same thing. All right, I would hope we get the same thing, just replace those two. So I'm going to have the limit as h approaches 0, taking my f of x plus h minus my f of x all over h. Okay, now this should look familiar again. We just talked about limits analytically the other day. If I plug my 0 in, notice I'm going to get 1 over x minus 1 over x, which is 0 over 0 indeterminate. So I've got to go, hopefully you're recognizing that complex fraction style. I'm going to put this over 1, and I'm just going to ask myself, what's the common denominator to clean this up? Well, look at all your denominators. You need the quantity x plus h. You need a plain old x and a 1, which is in every problem. So I'm going to multiply every term by x and x plus h. Notice, again, it's to the numerator. All right, let's clean this puppy up. The x plus h's are gone. So I still haven't plugged in the 0, the limit as h approaches 0. And what am I saying? I'm left with x minus, notice my brackets again. The x's are gone, so I have x plus h all over, and just like before, nothing's canceling because 1's not going to cancel with any of that junk. So I have an x plus h, and I have a plain old h. As I clean up the top, I'm going to distribute this negative sign in. So I get a negative x and a negative h. So I have a negative h all over x plus h, and h. I can kill the h's. So I'm left with -1 over x plus h. Lastly, I need to substitute in my 0 into the h, because this is h approaches 0. And I get a derivative of, so remember this is the derivative, -1 over x squared. Remember that turns into a 0, x times x is x squared. Now, the whole point was to write the equation of the tangent line. And if I scroll back up, my slope was -3, comma -1/3. And now I have my slope. My slope is -1 over x squared. Now I can't plug a function in. I want the slope when the x value is -3. So I get -1 over 9. Remember, we know the x value. So as I put this all together, I should have y plus 1/3 equals -1/9 times x plus 3. And remember, the nice part about the AP exam is this is full credit. Do not waste your time distributing that number and cleaning it up unless it's a multiple choice question and you have to. All right, last question for the night. Find the equation of a line. There's that question again. So what's going through your head? Before I even read any further, you should be saying to yourself, I need y minus y1 equals m times x minus x1. I need a point and I need a slope. Remember, the point is algebra 2, slope is calculus. If I keep reading, that is tangent to the graph and parallel, there's another key word, to the given line. Well, what do you know about parallel lines? Remember, parallel lines have the same slope. So that word gives really the whole problem away. So I'm going to start by saying this equation and this equation should have the same slope. Now, one of them, again, is very simple to do. You could have done in Algebra 1, and one of them we need Calculus 4. Obviously, because this one's linear, this is the one we could have done in just plain old algebra. I can easily get the slope of this equation by solving for y, and then looking at that coefficient of x. So I would say -3y equals -4x minus 5. Divide every term I see by -3. And I've got y equals 4/3 x plus 5/3. Therefore, this guy has a slope of 4/3. Now remember, we said that parallel lines have equal slopes. So now that I found the slope of this equation, I need to find the slope of this equation. And to do that, because it's not linear, I need calculus. So let's use that definition of the derivative, the limit as h approaches 0 of f of x plus h minus f of x all over h to calculate its slope. So why don't you pause it, get your slope, see if it matches with mine. Hopefully you've got that same answer. Now that we said they have the same slope, I'm going to set the two slope equations equal to each other. So I've got 2x for one slope, and because it said parallel, that means it's equal to 4/3. And all I'm going to do is solve for x, and that will get me the x coordinate. So again, instead of saying divide by 2, I think it's easier to multiply by the reciprocal. Those of you that have fraction issues, we'll just say times 1/2 to both sides. Obviously, that's 2 over 1. Those would cancel, and I will get x equals 4 over 6, or 2/3. Now that I know the x value, all I have to do is evaluate the y value. So I'm going to find f of 2/3. And my function again was x squared. So if I square 2/3, I should get 4/9. And that would get me my y value. So now I have an x value, I have a y value, and I know my slope is 4/3. So I'm going to say y minus 4/9 equals 4/3 times x minus 2/3. And there you have it. So that was our last problem for the night. Again, anything you get stuck on, take your time, go back, rewind, and replay so you're fresh and ready for tomorrow. Have a great night.